All right, let's get right into it. Today, we're tearing down a really ambitious investment document for a platform that claims it can build an AI engine to completely revolutionize biological research. Seriously, it's a bold claim. So let's see if the hype is real.
And right off the bat, to understand the stakes, you got to start with this number. The market this platform is gunning for, bioinformatics software, is worth over $28 billion. So look, we're not talking about some small niche app. This is about disrupting a massive foundational industry.
So why is this huge industry ripe for disruption? Well, this quote from the document gets right to the heart of it. The way we analyze genetic data right now, it's kind of broken. It's painfully slow, it's incredibly manual, and it just can't keep up with the tsunami of data we're generating. This bottleneck is the exact problem this whole platform is designed to smash. So here's our roadmap for today. First, we're going to unpack that billion-dollar bottleneck. Then, we'll get into the autonomous engine they've designed to fix it. After that, we'll dive into the profit plan, see how they plan to build a moat around their business. And finally, we'll look at their grand vision for the future of medicine.
Okay, Section 1, Biology's billion-dollar bottleneck. Let's really dig in and get a feel for what this manual analysis crisis is all about.
First up, just a quick level set so we're all on the same page. When we say bioinformatics, what are we talking about? Well, think of it as using super powerful computers to make sense of gigantic biological data sets, like, our own DNA. It's where biology meets big data.
And this is where that crisis becomes real. Get this, 85% of this work is still done by hand, by human experts. A single deep analysis can take anywhere from 6 months to a year and a half. And what's worse, because it relies on people, 2 different teams analyzing the exact same data can get results that vary by up to 40%. It's slow, it's expensive, and it's wildly inconsistent.
So that's the problem. Now let's talk about the solution. Section 2, the autonomous science engine. This is the platform's answer to that crisis, and its entire value is built on what they call 4 key pillars of performance.
Pillar number 1 is a massive, massive leap in speed. The platform is promising an 80% reduction in analysis time. So you remember that 6 to 18-month process we just talked about? This thing supposedly crunches it down to just a few weeks. That is a total game changer for the pace of scientific research.
The second pillar is accuracy. This one takes aim directly at that 40% variation we saw with the manual process. The platform claims over 95% accuracy, basically swapping out human inconsistency for machine-level precision. This means researchers can finally trust that their results are repeatable and reliable every single time.
Third, and this might be the most ambitious one of them all, 100% automation. This isn't just about making things faster, it's about changing what a scientist even does. The goal here is to automate all the tedious, repetitive grunt work, freeing up these brilliant minds to focus on what they do best, asking the big questions and dreaming up the next big breakthrough.
And the fourth pillar that ties it all together is scale. This platform is built from the ground up to handle the kind of massive, complex data sets that are now the norm in biology. We're talking about analyzing over 1,000 genes at once, a scale that just completely overwhelms the old way of doing things and opens the door to totally new kinds of studies.
Now, let's just put it all side by side, because this slide really drives the point home. It shows the whole transformation. You go from a process that takes months, is mostly manual, and gives you inconsistent results, to one that takes weeks, is fully automated, and is incredibly precise. This is the core sales pitch, right here in a single snapshot.
Okay, having revolutionary technology is one thing, but building a profitable business, that's a whole other story. So let's move on to Section 3 and see how this platform actually plans to make money.
So the revenue model is built pretty heavily on recurring software subscriptions. 65% of their revenue is projected to come from licensing the platform out to big pharma companies and research labs. This is the classic high-margin software as a service, or SaaS, playbook that investors love to see.
Now, for customers, the million-dollar question, literally, is about the return on investment. The document makes a pretty compelling case. It argues that for a multi-million-dollar annual license, a company could see a return of $10 to $50 million in cost savings and efficiency gains. That's a 3 to 15 times return on their money. That's an argument that's going to get any CFO's attention.
And for the investors, this is the number that really makes their ears perk up, the LTV to CAC ratio. That stands for lifetime value over customer acquisition cost. In simple terms, it's the ultimate measure of how efficient a business is. It asks, for every dollar we spend to get a new customer, how many dollars do they give us back over time? They're projecting a ratio of 20 to 75x. Now, just for context, in the software world, a ratio of 3x is good. Over 10x is considered world-class. A number this high, it signals a potentially ridiculously profitable business model.
So the tech is impressive, and the economics look fantastic. But what's to stop a tech giant from just swooping in and building their own version? Let's get into Section 4, Building an Unbeatable Moat. How do they defend this thing?
Well, their defense rests on what they claim are totally unique capabilities. It's a combination of a super complex 3-layer AI architecture that supposedly mimics how human scientists think, the fact that it's the only truly 100% automated platform from start to finish, and this is critical, its ability to fuse all the major siloed biological databases into one single source of truth.
And this slide lays out the mountain any rival would have to climb. It would take them, 3 to 5 years just to replicate the core AI? Then they'd have to somehow build all the same database partnerships, hire a team with incredibly rare expertise, and then spend years validating their results to prove they're even in the same ballpark on accuracy. That head start is the moat.
Okay, let's zoom out for the big finish. Section 5, the future of medicine. This is the long-term vision, their go-to-market strategy, and their ultimate financial ambitions.
The strategy itself is really methodical. It's a 3-act play. Act 1, the first year, is all about proving the tech works with a small group of early adopters. Act 2, the next couple years, is about scaling up and becoming the clear industry leader. And Act 3, that's the dominance phase, capturing a majority share of the entire market.
And if that plan works, this is what that dominance is supposed to look like in dollars and cents. The projections are, let's be honest, aggressive, scaling from tens of millions in year 1 to over $500 million by year 5. This chart shows the kind of exponential hockey stick growth they believe their market position is going to unlock.
So really, it all boils down to this single powerful statement. The investment thesis isn't just about buying a piece of a company, it's about investing in what they claim will become the essential infrastructure for the entire field of genomics. A tool so fundamental that, if they're right, modern biological discovery just won't be possible without it.
Which leaves us with this final thought to chew on. This platform, as ambitious as it is just one piece of a much larger puzzle. It represents a fundamental shift away from manual, human-led discovery to automated, AI-driven science. So the ultimate question isn't just about whether this one company succeeds, but whether this kind of technology truly is the new engine of modern medicine itself.